Hi everyone, welcome to Chapter 4, the chapter on discrete random variables. Remember to use your pause button if I'm going too fast so you can catch up, okay? So, probability distribution function for a discrete random variable. So discrete random variable is one which the values that it can take are going to be countable, right? So you're going to see an example here about Jeremiah. He has 2 practices per week, so the number of times he attends is the random variable. So he can attend 0, 1, or 2 times. That's why it's discrete. He can't attend like pi times, right? He can't attend some continuous amount of times. It's going to be countable. All right, so a discrete PDF has 2 characteristics. Each probability is between 0 and 1. The sum of all the probabilities is 1. So we got Jeremiah down here, and he has practice 2 times per week. 90% of the time he goes to both practices. 8% of the time he goes to 1 practice, and 2% of the time he goes to 0 practices. So the random variable is the number of practices Jeremiah attends in a week. So x could be 0, 1, or 2. So the probability he attends both practices, 0.9. 1 practice, 0.08, and 2 practices, 0.02, or 0 practices, 0.02. So we know that the probabilities are all between 0 and 1, so that's good. And we know all the probabilities add up to 1. So it is a PDF, a discrete PDF. All right? The mean, or expected value, and standard deviation. So the expected value is we add up, that's what this letter means, that's the Greek letter sigma, that means add up x times p of x. So we look at our table here, and we do 2 times 0.09 plus 1 times 0.08 plus 0 times 0.02. And that's what I did right here. So Jeremiah is expected to attend, on average, 1.88 practices per week. The standard deviation is going to be sigma squared is the variance, right? So I figure the variance using that formula and then square root it, and I have the standard deviation. That may come up on the homework, I'm not sure, but you would just use that formula to take care of business. We're going to use the calculator, as you'll see here in a minute. Okay, hospital researchers interested in the number of times the average post-op patient will ring the nurse during a 12-hour shift. For a random sample of 50 patients, the following information was obtained. What is the expected value? What is the standard deviation? So the easiest way to do this is to put it in stat edit, then run 1var stats with L1 is the list and L2 is the freak list. Then x bar is 2.32 and sx is 1.22 are your expected value and standard deviation. I'm going to pause it and enter those in my calculator and then show you. Okay, so here we go. This is what I entered in my calculator. Well, first of all, let me show you my list. So I go to stat edit and I enter all this stuff in my list for L1 and L2. Then I go over to stat and to calc, and I'm going to do a 1var stats on it. Make sure you have L1 as your list and L2 as your freak list. And then we go down here and hit calculate, and there we have it. So I have my mean is 2.32. My standard deviation, it's really a standard deviation of a sample, but when you put the probabilities in for the frequencies instead of the numbers, it doesn't give you the S sub x. So 1.224 is going to be the standard deviation, 2.32 is the mean. And there you go, that's what I have written in right there. 2.32 standard deviation, 2.32 mean, 1.22 standard deviation. Okay, so one of the major discrete PDFs is the binomial distribution. So a binomial experiment has the following characteristics. There are a fixed number of trials or repetitions, n. There are 2 possible outcomes, either success or failure. P is the probability of success. Since you can only either succeed or fail, 1 minus P is going to be the failure. Okay? So the N trials are independent and repeated using identical conditions. So if X is the number of successes obtained in N independent trials, the mean, mu, is N times P. The standard deviation, sigma, is radical NPQ. All right, so a trainer is teaching a dolphin to do tricks. The probability the dolphin performs the trick is 35%. So the probability it does not is going to be 65%, right? 1 minus 0.35 is 0.65. Out of the 20 attempts, how many times will a dolphin succeed on average? So they're asking for the expected value. And then what is the standard deviation? So mean, or expected value, N times P, we expect the dolphin to succeed 20 times 0.35, or 7 times in that 20 attempts. Standard deviation, radical NPQ, just make the 20 times 0.35 times 0.65 and then square root it, you get 2.13. The notation for binomial distribution. So X is binomial, capital B, N is the number of trials, P is the probability of success. So that says X is a random variable with a binomial distribution. All right. Let's do an example. This example has a lot of words and uses double negatives and stuff. It has been stated that about 41% of adult workers have a high school diploma but do not pursue any further education. So actually the probability of success is not pursuing any further education with a high school diploma, 0.41. So if 20 adult workers are randomly selected, find the probability that at most 12 of them have a high school diploma. So X is number of workers with a high school diploma that are not pursuing higher education. All right, so we're looking for the probability that X is less than or equal to 12. We're going to use our calculator to do these. Your calculator is equipped with 2 different binomial applications, binom CDF and binom PDF. The C stands for cumulative and the P for particular. So anytime you have an inequality like that, you're going to use a cumulative. All right, so what that's saying is up to and including 12. So the probability that 12 or fewer workers have a high school diploma but are not pursuing any further education out of the 20 that we're seeking. So probability 0 have a high school diploma and don't pursue, plus probability 1 have a high school diploma and don't pursue, plus etc. all the way up to 12. Your calculator, the binom CDF function, gives you that exact probability. So let's see what it looks like on the calculator. Binom CDF, here we go. So I go to second, vars, gets us to the distribution menu. The easiest way to get to binom CDF and PDF is to use the up arrow, because otherwise you got to go around the horn like the slotted pig in Toy Story 2. So the binom CDF, right there, we got 20 trials. You got a p-value of 0.41. The x value is 12 because I'm going up to and including 12. So paste, enter, 0.9738. So 97.38% of the time that we survey 20 people, 12 or fewer will have a high school diploma but not be pursuing higher ed. That's a mouthful. All right. If we want to know the probability exactly 12 have a high school diploma but aren't pursuing any higher ed, we would use binom PDF. So same deal, second, distra, binom PDF right there, trials 20 again. Our probability value is 0.41 and our x value is exactly 12. Paste a Rooney and we get 0.0417. So 4.17% of the time, exactly 12 people out of the 20 surveyed will have a high school diploma but not be pursuing higher ed. Whew. What if I asked what's the probability at least 12 have high school diplomas? So at least 12 means x is greater than or equal to 12. Hey, your calculator doesn't give you that calculation. It gives you less than or equal to. So, you're either greater than or equal to 12 or less than or equal to 11. Those are complements. So we're using what we learned about complements in chapter 3, and we're going to do 1 minus probability x is less than or equal to 11. All right, so let's go to our calculator. We got 1 minus second Distra binom CDF trials 20, probability of success 0.41, and my x value is 11 because I'm subtracting out 0 through 11 in order to get me 12 or more. Remember, binom CDF is going to give you the lowest value all the way up to the value you choose, so 0 to 11 in this case. All right, so 1 minus that gives us 12 and above. So there you go. So 6.79% of the time, 12 or more people will, what is it again? Have a high school diploma, but not be pursuing any higher education. The last type of one you're going to see on these MyOpen Math assignments is, what if you have the probability between 10 and 14 inclusive? So we got to have probability of 10 plus probability of 11 plus probability of 12, etc. So you could use binom PDF 5 times in order to add all those up. Or we could use what we know about subtracting off a different probability. So probability between 10 and 14 is going to be the probability x is less than or equal to 14. So that's going to be 14, 13, 12, 11, 10, 9, 8, 7, all the way down to 0, minus probability x is less than or equal to 9. So we're subtracting off probability x equals 9, plus probability x equals 8, etc. So if I subtract off 9 through 0 from 14 through 0, I'm left with 14 through 10. So we would do this calculation here, binom CDF with the 14 minus binom CDF with the 9, subtract them. So 27.26% of the time between 10 and 14 people out of those 20 surveyed will have a high school diploma, but not be pursuing higher education. Whew, so I hope all that made sense. So you're definitely going to see one of those on the midterm, I promise you. And you're going to see a few of them on the homework assignments for this chapter. So it'll give you ample practice. All right, the other kind of binomial or of discrete probability distribution we're concerned with in this chapter is the Poisson distribution. Not Poisson distribution, it's got 2 S's, so Poisson. All right, 2 main characteristics. It gives the probability of a number of events occurring in a fixed interval of time or space if these events happen with a known average rate and independently of the time since the last event. So, an example, 5 words are misspelled on average in 100 pages of a particular book. All right, and the other characteristic, it may be used to approximate the binomial if the probability of success is small, such as 1%, and the number of trials is large, such as 1,000. All right. Notation. If x is the number of occurrences in the interval of interest, then x is Poisson, and the argument is mu, which is the mean for the interval of interest. All right. That big P in this case means Poisson, not probability. Okay. Let's do an example. An electronics store expects to have 10 returns per day on average. What is the probability there are less than 8 returns on any given day? All right, so the probability there are less than 8 returns, if x is the number of returns the store has on a given day, then x is Poisson with a mean of 10. All right, so probability less than 8 returns. You know, I think I probably made a mistake here because Poisson is going to give you, Poisson PDF is going to give you up to and including a number. So I'm going to have to fix this for your notes. But if I go up to and including a number, this should have been x is less than or equal to 7. Okay? And this would have been 10, 7. Okay? If it's because less than 8 means x is less than or equal to 7. So we go Poisson CDF with a 10, comma 7. So let's see what we're going to end up with here. This is going to be different then. So, second, Distra again, Poisson CDF. We got the mu value is 10. They use this lambda, but it's 10, and they want an x value of 7. So that's going to give less than or equal to 7. Paste it, and you get 0.2202. Okay, 0.2202. Leah's answering machine receives about 6 telephone calls between 8 a.m. and 10 a.m. What is the probability that Leah receives more than one call in the next 15 minutes? So because the problem asks about a 15-minute interval, we need to calculate how many calls she gets on average in 15 minutes. So from 8 a.m. to 10 a.m. is 120 minutes. So what portion do those 15 minutes represent? Okay, so she gets 6 in 120 minutes. So what's the expected number of calls she gets in 15 minutes? So I could set up this proportion here. We're going to set up that proportion, and I'm going to solve for x. So she's going to be expecting to get about 3/4 of a call every 15 minutes. So what's the probability she receives more than one call? More than one is going to be 1 minus probability x is less than or equal to 1. Right? So we're going to Poisson CDF 0.75 with 1 and subtract it from 1. So 17.34% of the time she expects to get more than one call on average in that 15 minutes. In the next 15 minutes, 17% of the time she's going to get more than one call. What's the probability she gets exactly 3 calls in the next 15 minutes? Well, I'd use the Poisson PDF distribution for that one. So Poisson PDF, we go up here, and then our lambda value is 10 again, and actually it wasn't 10, it's 0.75. I'm in a different example, silly. Okay, so let's clear that out. We want to put 0.75, and we want an x value of 3. And so 3.32% of the time, she'll get exactly 3 calls in the next 15 minutes. So that is the binomial and Poisson distributions as part of the discrete distribution chapter. Next chapter we'll be doing the uniform distribution and talking about continuous probability distribution functions. There it is. Hope you enjoyed the chapter 4 lesson. We'll see you later.